All right, three forces act on a ball. F1 is 4i minus 5j, F2 is 10i plus 2j, and F3 is negative 6i plus 7j. They want us to determine the resultant force and the magnitude and angle R makes with the I-axis. So our resultant force is just the sum of all forces. So let R be the resultant force and R is the sum of all forces, and that just means F1 plus F2 plus F3, and they're already all in component form. All I need to do is sum my I components and my j components. So 4 minus 5. And that's going to be 4 plus 10 minus 6 I plus negative 5 plus 2 plus 7j, and I end up with 8i plus 4j. So that's my resultant vector, my resultant force, the magnitude of that. So magnitude is how big it is, the size of it. Is our square root of x squared plus y squared, and that's going to be 8 squared plus 4 squared, and that will be root 80, which is 4 root 5, and force is measured in newtons. Now they want the angle that it makes with the I-axis, and for that we need to actually just do a quick sketch of R so that we get our angle correct. All right, so if we do a quick sketch, we know that R is 8i plus 4j, so here's our reference axis. I and j, 2, 3, 4, 5. Okay, so we're going up in twos. So I've got, what was it, 8i? Oh, wrong way around. Let's just go up in twos here. 8i, 4j, there we go. There is our vector, our R, and that's 8 and 4. And the angle I'm interested in here is theta. And as soon as we've got that, we can actually see where we're working and what we're doing, because we've got an opposite, we've got an adjacent, we've got an hypotenuse. So opposite over adjacent will be tan of theta. So tan of theta is opposite over adjacent. It will be 4 over 8, and theta will be inverse tan of a half, and that's going to be 26.6 degrees. So therefore the resultant force is 4 root 5 newtons at 26.6 degrees to the x-axis.